Welcome. This is Cyber Kumite, and this is Chris Lerno without Tim Wainwright this week. We are taking another quick break from arguing with each other to talk to Evan about his new free open source tool that he has developed called Dredd. Today's Kumite is brought to you by Rico Cybertron, appointed to be the best security company in the year 2139 and specializing in robotic process automation with the use of ABC Warrior robots. Why defend your network when you can instead eliminate all other networks? It's Rico Cybertron. Evan, thanks so much for joining us. This is your first Kumite, and you're the author of the tool Dredd and therefore have given it its name. So no better way to kick off this Kumite. We try to ask people in 60 seconds or less to explain what it is, but I don't think we've ever stuck to that except for one time. So in 60 seconds or less or more, what is Dredd?
All right, so Dredd is a utility I created to help automate the process of analyzing detection rules against attacker logs. So right now it supports analyzing Suricata rules against PCAPS, as well as Sigma rules against Mordor datasets. And Mordor datasets are essentially attacker behaviors exported from Windows logs via WinLogBeat.
Wow, that was fast. You did it in like almost 30 seconds. That's really great. Evan has both experience on the red team side being an attacker. That was kind of your first and foremost, but also significant experience now in defending and creating some of our purple team test cases and developing ways to better detect them. So Evan, what problem does Dredd help the blue teamers solve? So if I'm on the blue team side, what would I use Dredd for?
So Dredd is kind of something you do on your own, in your own VM, to kind of quickly iterate over rule development. So if you're trying to develop, say, new content rules for your SIM and you want to detect or to develop those rules out, try them against different types of behaviors to see if they work against that, it really kind of shines in those types of scenarios, especially environments where querying the SIM or other detection platforms is kind of more restricted, right? If you have limitations on your query rates because of performance reasons or licensing reasons, then having something that can act as a proxy for those is really useful. You can also use it to kind of evaluate your existing rules by taking those rules, dropping them in Dredd, and then evaluating them against different scenarios as they're stored in logs.
Gotcha. So you mentioned in your intro that you can pull those logs from data sets like Mordor and others. So what's supported here? What can someone evaluate their rules against right now?
Yeah, so right now it's focused on two main use cases. The first being the SIM and the second being network IPS, IDS type platforms. So for SIM, it supports the analysis of Sigma rules. So Sigma is a SIM agnostic rule standard that lets you translate these specific rules written for Sigma to platforms like Splunk, QRadar, Elastic. I think they have at least 20 different platforms they can support. So Dredd will take those rules, convert them, and then run them against it spins up an Elasticsearch container and then translates all the Sigma rules to Elastic and then runs those analyses. But you can then take those rules once you know they're in a good spot and convert them to whatever platform you need it for. Yeah. And then, so like I was saying, it supports Mordor data, but really it'll take any type of Windows logs that were exported from WinLogBeat. So it'll also support, if you want to use event log files and then convert those over, you can use those as well. And then for the IDS IPS piece, it'll support Suricata and Snort rules, since they're the same rule format. It'll take those and work against PCAPS.
Very cool. Very cool. So that's in a nutshell the blue team side. What about the red side? Do they have any use for this tool? Or is this all blue?
So there's definitely red use cases. Like you said, I do have red background, so I can definitely shine some light on this. I think where this kind of comes into play for the red teamers is that it really helps them kind of improve their existing methodologies or kind of iterate over them or help them develop new ones by taking those either publicly available detection rules, or if you're part of an internal red team, taking the detection rules from your existing detection platforms, taking them and then evaluating them against your own methodology. So you can perform your methodologies in, say, a testing environment, get those logs, and then start evaluating them against those detections so that you know before you even do those methodologies whether or not they're going to be effective. And then what it also helps you do, it kind of helps you develop a canon of what are common detection strategies within rules. So as you start to analyze your methodologies more and more, you kind of get a better understanding of what's common. And then so when you're developing new methodologies, you can avoid those things.
That I got it. That makes sense. So when you were developing Dredd, what was there? Are there other things that do similar functionality to Dredd? Was there a problem you needed to solve here, or is this the first kind of tool like this that allows you to do this type of evaluation on the red and blue side?
So I don't know that there's many other tools that kind of fill this gap. It's definitely a bit more niche. I was inspired a bit by two different things. One being the Mortar project itself. I really like the idea of the Mortar project, since its kind of mission statement is to say, let's avoid all the need to set up a test environment, get those attacker TTPs done, and get the logs recorded. Let's just skip ahead, get the logs, and then we can distribute those to anyone to develop that detection content themselves. Right.
Gotcha.
So you when a new like TTP comes out, you're not having to ask yourself, all right, how am I going to get this tested and see if it works, if our detections work. You can just skip ahead and go right to the detection development.
Yeah.
And then the other part was with a conversation with one of my colleagues, Brandon, kind of working on some internal detection stuff for our Purple Teams program, developing some Sigma rules, like a standard set of like good baseline detections. So having the ability to be able to query that quickly, right? So one of the bigger downsides of detection development when you're building out these sim rules is that you have to contend with all of the logs that are already in your sim, right? And if there's a ton of data, then those types of queries are going to take longer to run, and it can kind of slow down that momentum. So if you can take those individual attacker logs one at a time and analyze those rules against them, it can go by pretty quickly.
Very cool.
So that was kind of the motivation for it. There aren't, like I was saying, I don't think there are many other tools that kind of fill this niche. Though I did see one that was kind of similar by, I believe, SecureWorks about PCAP analysis, kind of along these lines.
Gotcha. When you look at doing this type of analysis on the blue team side, what I'm hearing is you can really use this to tune your tools against very specific types of attacks, because you've got pretty good data to go off of, pretty good logs that basically have emulated that attack almost exactly. So I'm hearing that it doesn't necessarily replace, for example, a live test case that you'd run in a purple team, but rather help you get to a better alert, a better rule that might help you detect during a purple team or a real attack in the environment. So it's not necessarily a replacement for that, but maybe something to help it along the way.
Yeah, this would definitely be something that you would do kind of in concert with a purple team. So where you'd have you could take those logs from that purple team of that attack, export those, and then begin to develop those detections against those logs so that you don't have to continually bug your red teamers to kind of help you do this. Or like I was saying, use your actual detection platform. You can then just take those individual logs and test those detections and iterate over them quickly.
Gotcha. One of the interesting things that I saw with the project was the ability to look at something and understand what it detect against multiple sets of data. So you've written a single rule, and that kind of leads, and you can look at a whole zip file worth of data, and did it detect in each one. That allows, in my mind, the ability to understand if the rule you've written is going to fire on a bunch of false positives or not. Was that what your idea was there?
Yeah, so out of the box, the tool is a command line tool, and it'll support two different types of kind of evaluations. So it'll take in multiple rules regardless, and it can also take in multiple data sets, and then you can have it output, like you were saying, either what the rules, how they evaluate it against the merged data, all of the data together, or against each data set individually.
Got it.
So you can kind of get a better breakdown. Alternatively, you can also import it as a Python library. So it's written in such a way that all of the functions are accessible as you would expect from a library. So if you wanted to write your own custom logic around how to evaluate it, you can, while getting all the benefits of how it would normally function.
Very cool. So you could throw essentially a bunch of data or logs in there that you know shouldn't fire, hoping that your rule doesn't fire on them, and then understand, oh man, this is way too general. I've got to do some work to tune here. That makes sense.
Yeah, that's a really good point. And it kind of goes into another piece of the tool, which is using it as part of a development process. So it has support for or it has a good use case within something like a CI/CD pipeline, continuous integration, continuous development. So if you were to say source control your detection logic as code and put it in a source repository, every time you make a change to that detection logic and then push that, you can evaluate them then against different types of rule sets. So you can, like you were saying, have benign ones to kind of do false positive testing. You can have logs that should fire. So you can do types of regression testing to make sure that you're not missing something that you would normally have coverage for.
Very cool. Evan, as in the movie Judge Dredd, we assume you're working to create more under the Janus projects. What are you working on next? Before you respond to that, though, another sponsor message from Rico Cybertron. Rico's predictive ransomware playbook eliminates future malware sources in their infancy, literally. Rico's ABC warriors travel back in time to judge, jury, and execute future malware authors. The future is a dangerous and brutal place, but you can trust your network security to Rico Cybertron. So, Evan, the question was, what are you working on next? Is Dredd something you're going to continue to work on? Is there another version, or is there another project you've been working with?
So a bit of both. I definitely want to continue to add functionality to Dredd, improve quality of life. Hopefully I can get some community feedback on it to kind of improve it, help steer the direction. I'm also working on another project that is more of a red team tool. So it'll be malleable payload creation. So you can pull in different modules to do different types of functionalities, which I think is a really interesting space. And I think it's going to get a little bit more attention going forward. We've already seen some stuff with some tools like Drop Engine, which was featured at Vegas this year, and then PEZOR, which came out a week or two before Vegas.
Very cool. Well, it sounds like maybe another Kumite in the works. Evan, I really appreciate your time with us today. I'm Chris Lerno, reminding you that Tim thinks he taught me everything I know. And I'm also just hoping that Evan uses his power for good and not to bring back an ABC Warrior robot to life.
Thanks, Chris. Appreciate you having me on.
Thanks, Evan.